Your stuff, and once that thing's up and at 'em, I'll throw our quiz up there in a second. So we're in chapter 6. Did you make it through chapter 5, 7, 5, 8 last night's homework?
Yeah, I got half, but then when it came to the
word problems, some of those at the end are tricky, aren't they?
I was good at them before, but now it's like I learned other things. I'm like,
It's all mixing together. Yeah. Some of them were hard. Grab Roberto, come to office. I just ran out of time. I mean, I wish I had time to do them all in here, but ran out of time in those last 3 or 4. Grab Roberto, there's his hours up there. Grab me, office hours. Grab me after class. I can usually answer at least one word problem after class, you know, if you wanted to see more of those. Glad to help. But I got to move on to chapter 6. All right, today we're going to cover 6.1, 6.2, 6.3 is the plan. That's a lot of stuff. Oh, did you miss it? I'm kidding. I'm just giving you a hard time. I haven't. I'm having technical issues, so I'll get it up in a minute. Yeah, you haven't missed anything. Yeah, you picked a perfect day. All right. So let me write this one. 56y to the 8th over 64 y to the 5th. Yeah, so what do they want us to simplify this fraction? So what do we do? I think you know, I don't think we really need me to say anything. How do you simplify the fraction 56 over 64? First of all, let's ignore the letters for a minute. What do you do? How do you reduce a fraction? Just divide whatever you can divide, huh? Yeah, just use your calculator. Like, I don't know everything. 2. For sure, 2. Well, actually, 8 would be the best thing, huh? Yeah, it'd be best if you did 8, but you could do 2 and then 2 again and then 2 one more time, or 2 and 4, or eventually just keep reducing it. Comment? No, we're going to in just a minute. The computer's having trouble coming up. Yeah, so we'll do the quiz in just a couple minutes. So that would be 7y to the 8th over 8y to the 5th. So far, so good? I just divide by 8, top and bottom. But you can divide by 2, divide by 4. Just keep dividing till it won't reduce anymore. And then we got to do the y's. What is it? Oh, thanks. It does matter. Yeah, I'm just getting old. I can't read it. I need to back up from everything now. All right, yeah, y to the 3rd. Thank you. On the bottom. Okay, now, so we did the numbers. Now, what do we do with y to the 8th over the y to the 3rd? We'll leave the 7 on the top, 8 on the bottom. What do we do with the y's? Yeah, you guys know these. We had these earlier, huh? Remember when you have the same letter vertical, you subtract them. If they're side by side, you add them. Remember those rules? So if they're vertical, you subtract them. And wherever the bigger one is, that's where the answer is. If the bigger one's on the bottom, the leftover's on the bottom. If the bigger one's on the top, the leftover after the subtraction is on the top. So it's y to the 5th on the top. And there's our answer. Hey, what if you're taking the multiple choice test, our next one's in a few weeks, and they put the y in the front instead of in the top? Is that the same answer? Should you grab that, or is that different? That's the same. Grab it if it's there. Yeah. Now why? Because that's over 1. Anything alone's over 1, so it's the same as being in the top. That make sense? Yeah, I'm trying to trick you. No, I'm trying to trick you now so you won't trick you on the test. Does that make sense? I'm just letting you know. It's the same either way. Math Excel will take it either way. Multiple choice test, grab it either way, right? To be alone is to be in the top. Because if you're alone, like y to the 5th alone, it's really over 1. Remember, anything alone is really over 1, so it's the same as being in the top. Yes. Yes, exactly. Good. You're dialed in right. Yeah, if the bigger one, yeah, let me put it over here. If it was like 7y to the 3rd over whatever, 8y to the 8th on the bottom, then yeah, the y to the 5th would be on the bottom in that case, huh? Yeah, exactly right. Wherever the bigger power is, that's where. And that would not be the same as putting it in the front. Because in the front, alone is really over 1. That'd be the top. That'd be wrong. So if this was the real answer, then I could not accept that version. Right? Everybody with me on that? These are the same. Right? Because to be alone is to be in the top. Anything on its own is really in the top. Are we good there? So this is not, yes, let me erase this. This is not the answer. All right, good. I think you've all got it. So let me move it over here. There it is. Okay, so 4 405, what, u to the 8th, y to the 7th, over 75, I can't read that. Is that u to the 6th?
Yeah.
Thanks. I'm just getting old. Y to the 5th. I never thought my eyes would fail, but they're failing. All right, so subtract. You don't need to hear my old guy stories, although I'm going to probably share with them throughout the semester. All right, anyway, so go ahead, take it from there. So reduce it. Use your calculator. That's a big number. I don't know it. I don't know it either off the top of my head. 405, 75. I have no idea.
When you're simplifying, would
Yeah.
you also end up simplifying the exponents also?
Yeah, so you subtract the powers, and you divide the numbers in the front, right? Like 5 goes into those two, right? So go ahead and just divide by 5, both those numbers in the front, right? So divide by 5, divide by 5. What is that, 81? And that's, what's the bottom, 15? Oh, we can divide by 3 again. Oh, it would have been better to do 15. Yeah, I didn't know. That's fine. You can do it one step, or you can, I'm going to have to do it again because I didn't get it all. That'd be what, 27 fifths? Yeah, it would have been quicker just divide by 15 top and bottom, but that's all right. However you need to get there. Just keep going and go until it won't go anymore. And now what about the letters? We subtract them, right? So u to the 8th over u to the 6th. So u squared on the top, y to the 7th over y to the 5th. So y squared on the top, done. Good? Everybody okay with that? Questions I can answer? So I just kept dividing the numbers in the front until they wouldn't reduce anymore. However you get there. You can do the 5 first, then the 3, or the 3, then the 5, or 15. One fell swoop. All right. Okay, so 8w minus 8 over 8w. All right. You ready? Go ahead and try that one.
That's negative 8.
Yeah, 8w minus 8 over 8w. Am I making any sense?
Well, no, the answer has to be negative 8, right?
Oh, okay. I didn't realize you were saying the answer. Yeah, does everybody have a chance? I want you to do it wrong so you'll learn and remember. There's a common mistake here, so I'm giving you a chance. I think you'll learn it better if you do it wrong first off. There's a temptation to go like that.
Yeah.
And say the answer is minus 8. Since I called it a temptation, you know it's not the truth, right? That's not right. That's not it. Why not? What's wrong with that?
It's 1 over 8.
It's on half.
Yeah, the subtraction is what? Yeah. Have I talked about the Costco glue thing?
What?
No. Okay. What? You're right. Good job. Yeah. Yes. Obviously, I have not. Pluses and minuses glue. It's my little thing. Plus and minuses glue things together. They glue things together. Kind of like shopping at Costco, right? We have 5 kids. My wife shops at Costco. You buy them both, right? You go to grab one milk. It's plastic or glued to another. You can't buy this one. You can't take your scissors to Costco and cut the thing. Thanks, I just want one. You can't do that. Sam's Club, those warehouse stores, right? You get a cheaper deal by buying a lot, right? So that's what pluses and minuses are like in algebra. That's a big deal. That rule will come up all the time. I'm telling my pre-calc students about that. I tell my calculus students about that because it comes up all the time. So remember this, pluses and minuses are like glue. They glue things together. What does that mean? Okay, so what? So let me come back here. When I say that these guys are glued, that means what? It's a package deal like Costco. You go like this and buy the whole package or you don't touch it. It's all or nothing because they're glued. And we think, well, we can't buy it all. Right, then we can't touch it. Not yet. We have to do something first. What do we do? Instead of all that, which is all wrong, and that's all wrong, what do we do instead? Factor the top. See that 8w minus 8 on the top? What can you take out? What do they have in common? Yeah, take it out. And just leave the 8 sitting on the bottom. And what does that leave in the parentheses? W, 8 times that and 8 times. Remember, you have to have it so that it would multiply and go back to the 8w minus 8.
Minus 1.
Minus 1, right? See, that's the same, huh? If I distributed that, 8w, 8 times 1, 8, it would go back. This distributed is the same as that. I haven't really changed anything. I factored it. Now, why? Why do we do that? Because now, that 8 is what? Times Meaning he's not glued, you can buy just one, like shopping at Save Mart or wherever. And so the answer is just W minus 1. We're done.
What happens?
What if I'm just
Oh, I just messed up and forgot about it. It's still there. I just forgot. So it's still there. So the final answer, let me try again, is, sorry guys, W minus 1 over W. Yeah, it just stays there. I can't cancel these because this is a package deal up top. It says buy all of me or don't touch me. I can't take the W, right? So I'm just done right there. That's as far as I can go because of the glue rule. Does that make sense? So the way we get around the glue rule is we factor. Did you notice when we factored on top, that makes it multiplied, huh? And then when it's multiplied, when we factored, that made it 8 times. And when it's times, you can cancel. And the bottom thing, you might think, well, yeah, what about the bottom? They're not glued either, right? The bottom is also just times, isn't it? So the bottom's like, yeah, you can buy just one. You can buy just one. But not this. This guy's glued. Says you buy the whole thing or nothing, right? The W minus 1. It's all or nothing. So what we're going to do really for the rest of these problems is we're going to factor. Because factoring makes it times. And then we can get around the glue rule. So that's why we're obsessed with factoring. That's why it's great that so many of you did well on the last exam. Factoring. Because if you're good at factoring, I mean, the rest of this course is not, in some ways, is not going to be that bad because it's got to be factoring all the time. We're just going to keep factoring and factoring. And if you're good at factoring, a lot of the problem will be solved for you already. Just factor. And then there's like one more little step. So, okay. So there you go. So it's, what is it, 5n squared plus 5n over 40n squared plus 25. I can't start canceling right now because everything's glued together. Instead, factor, huh? So factor the top, factor the bottom. You can take out what's in common, you know, like we did on the last exam, all that factoring stuff. So factor the top, factor the bottom.
So it's N.
You good with the top there? How does that top factor? What do 5n squared and 5n both have? They both have a 5 and they both have an n, huh? Yeah, so 5n times what? Times n would go back to 5n squared, huh? And then 5n times 1 would go back to 5n, huh? Good on the top so far? See how if I distributed that, it would go back to 5n squared plus 5n? And now the bottom, what goes into 40 and into 25? 5 and in again, huh? And then put in the inside whatever works. Whatever would multiply to go back. Use your calculator if you're rusty on some of those times tables. Just whatever would multiply. So 5n times what would go back to 40n squared?
8.
8n. And 5n times what would go back to 25n? Plus 5. Now, we've made it into times. Right? This is 5n times and 5n times. So that allows you to cancel times things. You just can't cancel added things, right? Because those are glued together. So the 5s and the n's can cancel, huh? Because they're just timesed. So that's fine. And what are we left with? N plus 1 over 8n plus 5. You don't even need the parentheses anymore because there's nothing to separate them from anymore. The 5n is gone from the front. Can I cancel like these n's now? No, because that's like a glued package, buy it all or buy nothing. So we can't buy it all, so we buy nothing. That's just it right there. Does that make sense? You get the hang of those rules? The pluses and minuses are like glue. They connect things together, make them a package deal. So that's why we're so into factoring. That's why it's so important that we did factoring well, because we'll just keep using factoring the rest of the course because it helps us. It makes the rules easier when you can factor things. Good, no questions? Yeah, factor the top factor. It's like 2 factoring problems in one, every one of these. I'm going to make that an x because my s's look like 5s. So x squared minus 10x plus 20. Yeah, so you're right. It's just factor the top, factor the bottom. And then cancel. No. Because we can't cancel right now because they're all glued.
This here. Depending fluid or harsh. This here.
All right, so how does that top factor? Yeah, what do you do with x squared minus 25? Yeah, remember the FL? Front times front, so that'd be x times x. Last times last, 5 and 5. And what signs do you need to make negative 25? 1 plus 1 minus? Good. There's the top. Now how about the bottom? The bottom is going to be FOIL. Remember, you multiply to be the back and you add to be the middle. Remember that? X is in the front. What two numbers multiply to be 25? 5 and 5. And what sign in the middle is negative 10? Both negative, right. So everybody good with that? Everybody see how the bottom is both negative? Because you got to make negative 10 in the middle. Remember, they got to add to be the middle. Negative 5 and negative 5 add to be negative 10 in the middle. And two negatives multiply to be positive 25 to the back. Remember how the back number is always, I don't know if you can read all my scribbling here. Let me make it a little neater. So the back number is multiply and the middle number is add, remember? So two negatives multiply to be positive 25 and they add to be negative 10, don't they? All right, so anyway, there's the factoring. So what matches?
Two package deals.
Yeah, two package deals. We can buy those package deals. We're buying the whole package, so that's fine. And then we're left with the x plus 5 and the x minus 5. Don't even need the parentheses anymore. I can't cancel those x's, can I? Because they're part of packages and we can't buy the whole package, so we're done right there. Is that good? Not making sense? It's really factoring. If you're a good factorer, it's not much new. All right, I got a trick one. Are you guys feeling tricky? Try that one. X squared plus 16 over x plus 4. Go ahead and simplify that. Can I just cancel the x's right now? No, package deal, got a factor. Got a factor. You want to
Let's go over 16. 14.
All right. Did you see the trick?
Yeah.
How do you factor the top?
You can't.
You may not. You may not factor the top.
No, I know that.
Remember? Really important that you remember that. We might think it will, no, isn't it x plus 4, x plus 4? No. It looks like it at first. It looks a lot like it at first. That's why it's tricky. Right? That's what I mean. Now you might, if the top was x squared minus 16, then yes, it would be x plus 4, x minus 4. You can factor FL with a minus, but you may not factor FL with plus. It can't be done. Why? Because it's just not true. Let's check it. Let me prove it to you. I've done it before, but let me prove it to you one more time. If you were to FOIL this out, it will not become x squared plus 16 because you'll get a middle term of plus 8. X squared plus 4x plus 4x plus 16. See what we get in the middle? 8x that was never really there. See, it's just not true. So you got to remember, it's hard to remember because it looks so good at first, doesn't it? It just looks right, but it's not right. So watch out for that. So you really want to put into your long-term clear memory, FL minus is okay. FL plus, you cannot do it. So if you got two terms with a plus, you can't do it. So that's all not right. So, okay, so here, let me get rid of this. So then what do? We can't factor the top. The top just stays as it is. It won't factor. And you can't factor the bottom. The bottom is just first power. Right? We only factor higher powers. The bottom is just x to the first power. You know what I mean? We can't do anything with the bottom. So we can't factor the top. The bottom, you never factor first power things. So what, can we cancel 4 into 16 4 times and x into one of those like that? No. Costco says no. Right? They're glued together. Costco says, you want to buy some of this? You buy that whole package or you don't touch it. Right? And I'm not buying the whole package. I'm trying to leave part, and I can't do that. So what do we do with this problem? Nothing. Leave it. They're tricking you to say, do you realize that cannot be simplified in any way, shape, or form? Oh, it's just first power? Yeah, good question. The bottom is just first power. We never factor a first power thing. We only factor higher powers, like second power, third power. Yeah, so the bottom we can't factor. The top, FL plus doesn't work. Nothing can be done. Let me make sure. Even if it was x squared plus 4 in the bottom, you can't. That's an FL plus. You can't factor it. You have to have minus in the middle.
So every column that'll have a plus on it probably wouldn't factor it?
Well, it won't factor as an FL. It can factor as other things. So let me show you what I mean by that. Yeah, let me be clear. Like, what if you had x squared plus 2x? You could factor that because they both have an x in common. You see what I mean? So when I say it won't factor as an FL, I mean that. I mean as the, FL is like if you had x squared minus 4x plus, it's two terms that you go front times front and last times last. That's what FL means. Front, last, right? See, that's correct, right? For minus, FL is doable. But if that was a plus 4, you cannot go x plus 2, x plus 2. That's not true, although it looks true. So that's what I'm saying. FL plus, that particular kind of plus factoring is not doable. Only FL minus. All right. Oh, yeah, good question. When I'm looking at that x squared, notice it's XX. That's what x squared means. And 16 is 4, 4. So an FL is when you see two things on the front and two things at the back. That's what you're looking for. So whereas, yeah. So we'll see it as ones for you guys. And your calculators. All right, let's try this one. 35v squared minus 875 over 49v squared minus 1225. Okay. So, I don't know off the top of my head, but looking, I bet that 875 is divisible by 35. I don't know. I'm guessing. Try your calculator. Take that thing and divide by 35. Does it go in? What is it, 25 times? Okay. So that means just take a 35 out of the top. You know what I mean? That means 35 goes into both of them, right? So that means take a 35 out. And 49, yeah, probably goes into both the ones on the bottom, huh? 25 also? Oh, wow. You guys getting that? And then you can just cancel these things, huh? That good? Question, James? Yeah, I'm taking the whole package there. So that leaves 35 over 49. I just divided by 49. So whenever you factor something out, like a 49 out, then divide that by 49. Because I don't tell you what multiplies to go back. Right? Whenever we factor, we're just finding what would multiply to return. So we good on that? Oh wait, that's not the answer. Why not? Yeah, that's divisible by 7. 5/7. I didn't notice that at first. Now it's good. Is that okay? Everybody see what we did there? So I just took a guess. I just know how they write these problems. when I saw that big old number, I thought, I bet that 35 goes into that, and I bet that 49 goes into the bottom one. That's just how they do these things. So, all right. Okay, so 5q plus 45 over q squared minus q minus 90. All right, so it's two factoring problems. Factor the top, factor the bottom. So what goes into 5q and 44? What do they both have in common on the top?
5.
Take out a 5. Is that good? And then on the bottom, you're looking for the 2 parentheses. What multiplies to be 90? What number is in the middle on the bottom? -1, huh? Yeah, -1. So you want q's in the front. You want 2 numbers that multiply to be 90. 90. What? Yeah, what multiplies to be 90? 10 and 9 is a good choice, huh? 9 and 10. And remember how the signs always go? Give you a second. Let me give you a second. Get those signs right. Remember, you look in the middle. Okay, so sign in the middle goes on the bigger number, huh? Remember how the sign in the middle, the 10 is bigger than the 9. So the sign in the middle is always taken by the bigger number. Remember that rule? So, and then the q plus 9's cancel. So we get 5 over q minus 10. We good there? That's it. Why can't I go 5 into 10? Yeah, glued on the bottom, so can't touch the bottom unless you buy it all. Good? All right, try that. I'm going to make it x's. 5x squared plus 35x plus 50 over 25x squared minus 75x minus 250. Got to factor top and bottom. Remember what the first step is, everybody, on when you're factoring? What's the first thing you try to do?
What they have in common.
What they have in common. Yeah, look at that top. See how 5 goes into all of them?
GCF.
Yeah, GCF. So do the 5. It's going to be more. This is going to be a longer one. But yeah, your first step on the top should be 5 with the one big parenthesis, right? And on the bottom, I think 25 with the one big parenthesis. And then next step, you'll have to do the 2 parentheses, right? So next step, you'll do the 2 parentheses on the top and the bottom. Yeah, so set it up like that. See if you can get that. So that first step. We good to there so far? See how I got those? I just went through and I divided, huh? When you take out a 5, I just went divide by 5, divide by 5. The bottom I went divide by 25, divide by 25. Whatever you put in the front, you're dividing those numbers by, huh? That's how I got the 7, the 10, the 3, and the 10. Okay, now we have to go further. Leave the 5 and the 25 in the front here. And then now we got to do the multiply add thing, huh? So what two x's in the front? What two numbers multiply to be 10? Yeah, 2 and 5, huh? And they add to be 7, good. And the bottom, what numbers multiply to be 10 and add to be minus 3? 2 and 5 again, but how do the signs go? Sign in the middle
The bigger number.
always goes on the bigger, right? So it'll be on the 5 and the plus on the 2, does that make sense? And then these guys cancel. Everybody good there? Is that making sense? One other thing though. What else can I reduce there? Yeah, 5 goes into 25 5 times. So the answer then is x plus 5 on the top. On the bottom, 5 and x minus 5. That's a 5 down there. We need to keep the parentheses on the bottom because there's something to separate it from. Comment, question? Oh, no, you don't have to. Yeah, 1 times anything is just itself, so there's no need for the 1.
So that's why you didn't put the one on the top.
Yeah, I mean, it's okay if you put it there like that.
I got you.
That's the same thing. But yeah, what is 1 times anything? It's just itself. Yeah. So we don't usually show ones. Good. Other questions on that one? That makes sense. Is that okay? See how we did that? So at the very end, see when we factor it, then it's times, and we can cancel. We can buy just 1. Right? 5 went into 25 5 times like that. Okay. Okay, so we have 5 minus y over y minus 5. What, can you just cancel those? I mean, it's like they're the same, but they're like in the opposite order. It turns out when you have minus in the middle between two things, you can switch the order if you put a -1 in the front. Let me prove it to you with numbers before we get started. Actually, before we even go further, what if they were plus? Let me ask that question. What if they were plus? Would that be different? Does the order of adding matter? No. Think about numbers. Think about, 3 plus 6. Is that any different than 6 plus 3? It's 9 either way, huh? So in other words, these guys would be the same. I would just cancel them and say it's 1. They would just totally cancel. They would if they were plus. If they're plus, who cares about the order? Right? The order of adding does not matter. Let me write that. Order of adding does not matter. So if two things are added, you can switch their order anytime you want, and it doesn't matter at all. But for subtracting, it does matter, huh? It's different, isn't it? Right? Let's go back and make it these. Let me give you an example of subtraction. How about 5 take 1 away, or 1 take 5 away? Is that different? Yeah. Very much so. This is 4. This is being in debt. -4. Been there, right? So that's different. The order of subtraction is important. The order of adding doesn't matter at all. So what do we do about all that? So what we do for subtracting, turn around the one with the letter at the back and put -1 factored in front. I call it the turnaround rule. So let me show you what I'm talking about. So we've got 5 minus y over y minus 5. So when you have, see how on the top, it's the letter is subtracted at the back? I'm saying turn around the one with the letter at the back and put a minus 1 in the front. So I'm going to take this one, because that one is the one that has the letter at the back. So turn it around like that and put a minus 1 in the front. Everybody see what I did there? I turned around the top and put a minus 1 factored in front. Everybody see that? So I just switched the order on the top and put a minus 1 factored in front. Yeah, it just, the negative 1 switches the order. Exactly. Is that good? So now they can just cancel, and the answer is just minus 1. We're done. I'd like to, I always want to show you that things are true. They're not just my little rule, let me show you that's true. What did we just do there? What is true? That if you have two things subtracted and you switch the order and put a minus 1 in front, you really haven't changed anything. It's legal, in other words. Let's try it out. What if you had 5 minus 8? Which is really what? What is 5 minus 8 really? Negative 3, right? What over whatever, blah, 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 who cares? And I switch the order and put a minus 1 in the front over, whatever, blah, blah, blah. That's what I'm saying you do, right? You switch the order. If you get the bigger one at the back, get the letter at the back, switch the order and put a minus 1 in the front. And it'll really be the same. Is it? Is it really the same? What is 8 minus 5? 3. What is minus 1 times 3? Minus 3. It's still minus 3. Now, I don't know if you're thinking, wait a minute, why didn't you distribute? Well, you could. I could have. Or you could just subtract them first, right? You can just do the parentheses first if you want. 8 minus 5 is 3, and negative 1 times 3. See how it's still negative 3? See how it's legal? I haven't really changed anything. I've just manipulated it so it'd be easier to cancel without really changing it. I mean, that's like 80% of math, is making things look different without being different, right? That's a lot of what we do. I always call it plastic surgery, removing the wrinkles so they look different, but it's the same person, right? I'm getting old, so maybe I'm just thinking about plastic surgery because I'm getting old. I don't know, but no, I've been doing this analogy for 20 years. So yeah, I guess it got burned in the sun. Anyway, so that analogy where I just think it's the perfect analogy, right? Because we're giving it a new look without really changing it. That's so much of math, is we do things like that. All right, does that make sense? So just turn it around, put a minus 1 on the front. It looks different, but it's not different, and then you can cancel. Okay, so 6x minus 30 over 5 minus x. That's a 5. My 5s look like S's. Okay, so try that. So first, start with, what are you going to do on the bottom? See how the x is subtracted at the back?
Turn around.
Flip it around and put a minus 1 in the front. That'll give it a new look, but it's really still the same, right? All right, so on the bottom, take out the minus 1 and turn it around. That good when you have the x subtracted to the back? What about the top? What can we do with the top?
6 x minus 5.
X minus 5, that good?
And just cancel.
Boom. Yeah, now we never leave 1s on the bottom, right? Or even a negative 1, because that'll always divide in. That's just negative 6, isn't it? That makes sense? Because, it's negative because it's one positive, 1 negative, so it's negative. 6 over 1 is just 6. Yeah, we never leave 1s on the bottom.
You would only
Right, yeah, right. If it was x minus 5, I wouldn't do that. Yeah, exactly.
I would only know to do that if the X was.
Subtracted at the back. Yeah, totally. Good point. I'm glad you brought that up. She's right on. Is everybody catching that? We only do this when the letter is subtracted at the back. If it was at the front, I would just leave it. I like it at the front. That's what I'm used to. That's fine and good. But when the x is subtracted at the back, exactly right. That was why I was having an issue. I don't like the x's subtracted at the back. I flip them around and put a minus 1 at the front, which really is the same. It just looks different. That makes it easier. Good. Okay, so we have 7y to the 7th over 10v to the 6th times 100v to the 8th over 49y. So now we're multiplying two fractions. And do you remember you can cross-cancel when you multiply fractions? Mm-hmm. Remember that kind of rule? Yep. You can totally do that here. So you can go like 7 goes into 49 7 times. By the way, notice nothing's glued. We're not shopping at Costco here.
Target.
We can buy just one. This is Target, this is Save Mart, whatever. You can buy just one. Right? Right? No pluses or minuses, right? There's no glue anywhere. 10 goes into 100. How many times? 10 times. So make sure you cross off stuff when you cancel it, so you know it's gone, so you don't get confused. So we have 10 on the top, 7 on the bottom. What about, so there's the numbers. Everybody okay with the numbers so far? Now what do we do with the letters? Yeah, so we have y to the 7th on the top, and y, what power is on the y that's on the bottom? Just 1, huh? So remember, you subtract them. Where's the y to the 6th end up? Top or bottom? On the top, because the bigger one's on the top. And the v's also on the top. And we're done. Is that good? Everybody okay with the cross-canceling of the numbers there? So all I did there is I divided. I just went divide by 7, divide by 7. Right? That leaves a 1, and that leaves a 7. Does that make sense? I just divided them both by 7. And these guys I divided by 10, divided by 10, left a 1 and a 10. And 1s don't mean anything. We don't leave, 1 times 10 is just 10. 1 times 7 is just 7. Does that make sense? What really happened? If you want more details, that's what happened there. Yeah.
How come the 10 is on top and not the 7? How do you know when you cross?
Oh, yeah, good. Good question. It's wherever the bigger number is, just like with the letters. Yeah, letters and numbers follow the same rule. Yeah, her question was good. She was like, well, how do you know? Okay, yeah, I know 10, 100 divided by 10 is 10 and everything, but how do you know whether it ends up on the top or the bottom? Well, the 100, the bigger one was on the top, so the 10 ends up on the top. It's the same rule for the numbers as it does for the letter and their powers. Wherever the bigger is, that's where the leftover ends up. So with the 7 and the 49, the bigger was on the bottom, so the 7 ended up on the bottom. So I'm really just dividing those. Is everybody okay about that? I just did 49 divided by 7, 7 on the bottom. 100 divided by 10, 10 on the top. Right? And then I subtract the powers. So you divide the numbers, subtract the powers. So x squared minus 3x minus 10. Squared minus 4x plus 4. Okay, so you have to factor that. The one on the right, the x minus 2 over x plus 5, that's just first power. That doesn't need to be factored. But the stuff on the left needs to be factored, huh? So factor this part here, and factor this part here. Probably you're going to have a match and some canceling will happen, would be my guess. So you're looking for multiply, add. All right, so what multiplies to be 10? What times what is 10?
2 and
5 and 2, 2 and 5, yeah, either order. How do we do the signs, though? Remember the sign that's in the
The bigger number.
sign that's in the middle always goes on the bigger, huh? So negative in the middle, negative on the 5, plus on the 2. Minus 5 plus 2 makes minus 3 in the middle. Okay. No, yeah, if you have the x plus 2 here first, and then the x minus 5, that's fine, as long as the signs are right. As long as the 5 has the negative, and the 2 has the positive, yeah, the order doesn't matter. And what about the bottom? We're going to have 2 and 2, both negative, huh? Because that makes negative 4. That adds to be negative 4 and multiplies to be plus 4. 2 negatives on the bottom. Does that make sense? So what cancels?
The x 5 and the x minus 2.
Yeah, right. So the x minus 5 and the x minus 2. And so what are we left with? Over x minus 2, like that. And there we go. Questions on that one? Question, James.
How can you enter x minus 2 into x minus?
Oh yeah, it's just 1 with 1. So you could have done this one instead, but you can't do 1 with 2. It's just 1 with 1. Yeah, either one. Doesn't matter which one. Yeah, good. Other questions on that? Does that make sense? Yes, everybody see Jim's question was doing just one of these with one of these. We don't do them both, right? Just one for one. Okay. All right, so y squared minus 64 over y squared times y squared minus 8y over y squared plus y minus 72. So it's like a bunch of factoring problems, huh? Just factor all those. How do you factor y squared minus 64? And that's the plus 8 minus 8, right? Hey, by the way, what if that had been y squared plus 64? Then you can't do it. Remember, you can't do it when it's plus in the middle. Anyway, but it's minus, so we can do it. 1 plus 1 minus. Everybody good so far? Now factor those other two. We do with the y squared minus 8 up there. I'm minus 8y. That's a take out y in common, huh? That's just they have y, they both have y in common. Remember, that's always the first thing you do is GCF, if it's there anyway. It's GCF. All right, take out a y. Is that good like that? And then on the bottom, we got to do like the 2 parentheses, y's in the front. What multiplies?
9 and 8.
Yeah, exactly. Use your calculator if you're rusty on some of those times tables. What multiplies? And the middle is a plus 1, huh? Adds to be plus 1 in the middle. So what times what is 72? Yeah, 9 times 8, huh?
Positive 9, -3.
Yeah, so 9 times 8, 72. And what, yeah, sign in the middle is plus, so sign on the bigger is plus. On the 9 is plus, the 8 is minus. That makes plus 1 in the middle, plus 9 minus 8. We good? So now it's all factored. So now, what can we cancel?
1 minus 8.
Yeah, the y minus 8's cancel, right? Everybody good with that? Cancel those. Anything else? One other little thing. Yeah, this y and y squared can subtract powers, huh? Because this is y to the 1 on the top and y to the 2 on the bottom. So that'll leave y to the 1, or just y on the bottom, along with the y plus 9 on the top, y plus 8, y minus 8, and we're done. Is that okay? Let's see what happened there. Everybody okay with all that factoring? Questions I can answer on all that factoring?
You have problems with S's, I got it with Y's and X's. Sometimes I don't get it all the way through, and my Y's look like an X.
I see. All right, so we all good? See how those y's? Can't remember, we had y squared on the bottom, y2 and y1 on the top. They subtract, and the bigger one's on the bottom, right? All right. Okay, let's try this one. I'm going to make that an x, because my t's look like plus signs. X to the 4th minus 256 over x to the 4th minus 1, x squared plus 1, x squared plus 16. Yeah, so try factoring all those. You know, when you look at that 256, and you might be thinking, now what times what is 256? What you could do is use the root button on your calculator. The root of 256, hit the root, and that'll tell you what times what is 256.
Isn't it this one here?
Yeah, but you gotta hit, it's above because you gotta hit shift.
You gotta hit shift and hit it.
Yeah,
Alright.
that's it. Yeah, whenever it's above because that's why the shift is yellow, orange. It's telling you need the orange stuff. You gotta hit shift down in the key. Yeah, all the keys can do two things. There, you guys got the root. So root of 256. Everybody find that in your calculator?
The root?
Yeah.
Go to root.
Right here.
Take
You
root.
gonna do that?
Take root 58, 49, 55. Now get all the way to root 256. You end up with root 16. Go click the right intersection to get to your destination.
You guys both have the same difficult technical. I don't know if you want to invest, but 10, 12, 13, Casio Natural Display. Much.
Bet.
Yes, same price.
Casino for the same.
Bookstore, Walmart, Target, Casio Natural Display. Way cheaper. Yeah. All right. So root of 256 is 16. Getting that? Now, who cares? What does that tell me? Well, that tells me I can do like 2 parentheses. Right? And do the FL thing. Right? Front times front. Remember the FL? You know what I'm talking about? I'm making some sense? Whoops. Got a weird color there. I mean front times front and last times last. So what front times front to be x to the 4th? X squared. That good? Remember, you want front times front to be front. X to the 4th. And you want last times last to be 256. That's 16 times 16. And you need 1 plus and 1 minus to be minus 256. Is that good to there? And then the bottom is also an FL. See what I mean by FL? Where FL means the two, it's just like FOIL, but it's easier. It's missing the OI in the middle. But it still means the two parentheses, front times front to be x to the fourth. X squared. Last times last to be 1. What times what is 1? Well, 1 and 1. And it's always 1 plus 1 minus, huh? Because positive times negative is negative 1, huh? Times. We good so far? Now, what about x squared plus 1? That looks like an FL also. Can I do the two parentheses, front times front, last times last? I cannot, right? That's what we were just talking about. FL plus is no further, right? Remember, FL plus. See, the first two were FL's minus, weren't they? Right? These first two were FL minus, huh? So those were doable, but the FL plus, that's what they're testing you on there. They want you to know it stays x squared plus 1, and it stays x squared plus 16. Yeah.
Why don't you do the x squared minus 16 again?
Yeah, I will. You're right. We're not done over there, are we? Now, everybody good to there so far? So far, so good? We got a little bit more. So that makes everybody see how these FLs on the right fraction are both plus, so they're not reducible, right? Good? Now, x squared plus 1, cross cancel. It's okay, I bought the whole package. Costco lets you do that, right? Right? They're glued together, but I bought the whole package. That's fine. If they're plus or minus, as long as you buy the whole thing, that's okay. X squared plus 16, x squared plus 16. Again, I bought the whole package, so that's fine. You just can't break the glue bond, right? You can't just take part of it. It's all or nothing. All right, where are we at now? X squared minus 16 over x squared minus 1. But those can reduce a little bit more, can't they? Right? This is an FL, two parentheses. The bottom is also, and they're FL minuses, so they can be done, right? You with me? So it's x, 4, 1 plus 1 minus. And the bottom is x, 1 times 1, 1 plus 1 minus. And that's our answer. Really, you could have left it right there. How do you know? If nothing else cancels, then it's really as simple as it can be at either one of these stages. Is that making sense? At both these points, both these are good final answers. Because in both cases, nothing more can cancel. So either one's good. We good there? We okay? All right. All right, so you tell me. I bet you know. How do you divide two fractions?
You use your calculator.
Which one do you flip? It's got to be the second one. Yeah, you're right. It's got to be the one on the right. You got to flip the second one. Remember that? Flip the right fraction and change to multiply. So we change to times. You got to flip the fraction on the right, like so. Is that good? So I've got to flip the fraction. It's called invert and multiply. A lot of people call that. You invert. You got to flip the one on the right. Change to times. Okay, we're to here. Now, how do we multiply? Now we've changed to times. How do we multiply those two fractions? You could go straight across, but what would be easier? It's cross cancel. 3 goes into 27. 9 times. So it's 7 over 18. Because 2 times 9. That good? See what happens? So I just flip the 1 on the right. Let me go through let me do an instant replay.
Book review.
One more time.
The Barcelona game.
So you change to times, and you flip the 1 on the right, and now 27 divided by 3, use your calculator, is 9. And the 9 ends up down by the bigger one, right? The 9's not up here because the 3 was smaller. It's always where the bigger one is when you divide two numbers, right? So it's down there. And now 2 doesn't go into 7. I would do it if I could, but it doesn't go. 2 doesn't go into 7, does it? Not evenly, right? So you can't do it. So you cross-cancel anything you can cross-cancel, and then the leftovers, you multiply. What's left over in the top is 7. What's left over in the bottom, 2 times 9, 18. That good? So dividing is just upside down multiplying, isn't it? Okay, so we have x squared minus 9 over x divided by x plus 3 over x plus 2. All right, you know what to do. Flip the 1 on the right, change the times.
Might tell us better.
So flip the 1. It's always the 1 on the right. You always got to flip the 1 on the right. Flip the 1 on the right, change to times. Now what? Well, now it's really a problem from the last section that we just finished, right? 6.1. It's a multiplying two fractions problem. How do we do that? What do we have to do with this x squared minus 9? Factor. It's an FL, isn't it? Just factor that FL, they cross cancel. FL minus. One plus one minus. Everybody good there? FL 1 plus 1 minus. X plus 3's cancel. And what are we left with? X minus 3, X plus 2 over X, and we're done. It's a big X on the bottom. And we're done. Is that okay? Everybody see that? Questions I can answer? Okay, let's try that one. We're dividing by, got the fraction on the right. Try that one. Flip that fraction on the right, right? And change to times. Please, in the back, if I'm hearing a little mumbling all the way up here, I just want to make sure that people around you can concentrate. Please just keep it to a whisper so nobody's distracted. Thank you. So, these guys got to be factored, don't they? Right? You got to factor those two. You know, let me say this. I'm trying to help you with trying to think of the easiest way to say this. See how the V's at the back? You don't really want letters at the back. That kind of messes things up. So really what you should do is reorder it like this. See that? Now I don't want to confuse you with the turnaround rule. That's not the turnaround rule. Am I confusing you? Why not? Remember the special rule we did a little bit ago where you turn around, you put a -1 in the front? That's not it. Because that didn't have a minus in the middle. Might confuse you, that's close, isn't it? But it's different. Do you see that? That's not the turnaround rule, because these are two things added. Remember, that's probably the easiest way to say it. Remember I said you could switch the order of added things anytime you want? Right? That's not the turnaround rule, where you got to put the -1 factored in the front. That's not that. You with me? Am I confusing you? The turnaround rule is when you have two things subtracted. These are not two things subtracted, they're two things added. So remember when I distinguished between those two rules? I said if you have two things added, you can switch them around all day. You don't need to put parentheses or -1s in the front. It doesn't matter. Right? Remember that? The order of adding two things, like, think about it. 7 plus 3, is that any different than 3 plus 7? No, it's 10 either way. Who cares? But if they're subtracted, you can't just be switching that. That's 4, and now it's -4. That's different, right? You got to put a -1 in the front with the parentheses, because that changes the sign, huh? So everybody seeing that difference? Is that clear? So if you have two things subtracted, we don't like letters at the back. Kind of messes us up. So I'm always going to try to turn things around and put the letters at the front. There's two ways we can do that turnaround. If they're added, just go ahead and turn it around. You don't need to put parentheses, -1 in the front or any of that. But if they're subtracted, when you turn it around, that's got to put a -1 in the front, doesn't it? It's going to change the sign. Does that make sense? So there's two kinds of turnarounds. We never like letters at the back. So I turn this one around. Let me do that. I grab this, turn around. 3V goes in the front. Is that good? Thought I was going to sneeze. Excuse me, I'm going to sneeze. Okay, so there we go. So we turn that one around like that. Now, can we factor? How do you factor this? Oh, by the way, what's plus a -3? You know, that's just 3V minus 3, isn't it? You don't need that plus a -3. That's just -3. So you can factor out a 3, huh? Everybody good there? Right, on the bottom, factor out a 49. Is that good? So again, from the beginning, dividing means flip the one on the right, change the times. Flip the one on the right, change the times. Right? It was a dividing problem in the beginning. Right? This is 6.2, dividing. So dividing means flip, turn the fraction on the right upside down and change from divide to times.
I thought it was a plus symbol up there.
That's a divide, yeah.
Okay.
And then we don't like letters at the back, so we turn them around with the letter in the front. Factor. And now, can we cancel anything? V minus 1s. Anything else? Yeah, you know that 11 goes into 121 11 times. You can divide them on your calculator. And what's left? 3 times 11 over 49, which is really 33. Over 49, huh? There we go. Is that good? Questions on that one? No questions? Okay, so x squared minus 25 over 36x plus 180 divided by... All right, so what do we do with dividing? Flip the one on the right. And change to times. All right, factor that left fraction. That left one needs to be factored. Use your calculator. When I look at that 36 and that 180, I bet 36 goes in there. Try dividing on your calculator. That's how they write these problems. All right, so this is an FL. It's minus, so we can do it. X is in the front, 5's at the back, 1 plus 1 minus. The bottom is take out an X, 36, and it's X plus 5, right? We good there? And then cancel. X plus 5, X plus 5, X minus 5, X minus 5. We're left with 30 over 36. Is that reducible? Divide by 6. 5/6. And we're good? Questions on that one? Good. Okay, I don't mean to rush you, but if you didn't get it, grab it on the YouTube later, because I got a whole... it's not GCF, it's LCM. Okay. So find the LCM of 10 and 4. What are they talking about? LCM is the same as LCD. In other words, pretend you have like 1/10 and 1/4, and you want to get the common denom. It's not 2, is it? 2 would be if you factored. Factoring is the opposite of what we're doing right now. So yeah, so it's kind of like they're saying, hey, what if you had 10 and 4 as denominators? What would be the common denominator? 20. Yeah. In other words, what number did 10 and 4 both go evenly into? What's the lowest common multiple? What's the lowest common? Because they both go into 40 also, don't they? But what's the lowest number they both go into? 20. 20 is the smallest number that 10 goes evenly into and 4 goes evenly into. Now, I want to give you a way to come up with this rather than just guessing around. So I'm going to show you what the trick I learned from Miss Nader. I don't know if anybody's had Miss Nader, but she has a nice little trick that I'd never seen. I taught for, 15 years before I came here, and I guess 14 years before I came here, and then I saw her trick. I liked it. Basically, she taught me this trick. She said, put the 10 and the 4 in a box. So I'll show you a little way. You put the 10. We already know the answer is 20, but let me show you how you would come up, because they're going to get hard. The numbers are going to get hard in a little bit. So what you do is you stick the 10 and the 4 in a box. It's kind of like an L, but it looks like an L, right? For LCD, or LCM, same thing. And then basically put out here whatever number divides into 10 and 4. That'd be the 2 that we were thinking of earlier, right? Doesn't 2 go into 10 and 4? So put a 2 out there. And then divide both those by the 2. Meaning 10 divided by 2 is 5. 4 divided by 2 is 2. Am I going too quick? Let me slow down there for a minute. Everybody see that? So when they give you a couple numbers, 10 and 4, they ask you for the LCM. Just put them in an L box and say, hey, what goes into 10 and 4? 2 does. 2 goes into 10 5 times. 2 goes into 4 2 times. Now, we'd like to do another layer if possible. What goes into 5 and into 2? Nothing. That means we're done. Yeah, have you seen this? Yeah. So now, do you guys have Miss Nader? No. But you've seen it anyway. Oh, does Avery do it too?
No, Mr. McDonald.
Oh, does Mr. McDonald do it? Yeah, good. Mr. McDonald. Wait, which McDonald? Yeah. Not Ronald. All right, you multiply those numbers together. 2 times 5, like an L. Going down, it's like the L thing still. You just go 2 times 5 times 2. What is that? 2 times 5 is 10. 2 times 5 times 2 times 5 is 10. Times 2 is 20, which we already knew. That'll always give you the LCM. Just like that. That'll give you the lowest number that 10 and 4 go into. That'd be the common denominator. See, they're getting us ready. Monday's going to be a big day. Fractions. Big, messy letter fractions. This is where it class starts to gear up a little bit. It's starting Monday. They're getting us ready for common denominators for Monday. That's what they're getting us ready for. So that's how you find a common denominator. Now, all right, so put the 4 and the 15 in the box. What goes into 4 and into 15? Nothing. There's no number that divides, other than 1. I mean, 1 goes into everything. So you can do 1 if you want. I mean, it really didn't get us anywhere. So then you multiply these together. 60. Yeah. 60. So really, we could have just multiplied the numbers together from the beginning. But that won't always work. That wouldn't have worked on the last one. We would have got 40. So you got to check them first to see if anything goes in. Good on that one? So nothing went in, so you just multiply them together. So the LCD is 60. That's the smallest number they both go evenly into. All right. Now, 4, 14, and 7, that's a 14 there, are all going to be in the same box. Now we're going to do 3 numbers in the box to find the LCD. So go over here and say, what number goes into 4, 14, and 7? Nothing. 7 doesn't go into all of them, right? 7 doesn't go into 4. And 2 goes into the first 2, but it doesn't go into 7. There's nothing that goes into all 3, but you can do 2 at a time, huh? Probably not. You can do just 2 at a time, and that's fine. So what goes into just 2 of them? 7 or 2, either one. I'll do 7 first. 7 goes into 14. 2 times. 7 goes into 7. 1 time. 7 does not go into 4, so you just bring it down. So far, so good? You could have started with the 2 instead of the 7. The order doesn't matter. I'm going to do another step now. Was everybody good so far? So I did 7 into the back 2, but it didn't go into 4, so I just brought the 4 down. Now, look at 4, 2, and 1. What goes into 2 of those numbers? 2, right? So do another layer. 2. 2 goes into 4. 2 times 2 goes into 2. 1 time. 2 doesn't go into 1, just bring it down. Now, what goes into... Now, some people call this the ladder method. It looks like it's a ladder or a birthday cake. It looks like whatever, lots of names. Anyway, what goes into 2, 1, and 1? 1, but 1 goes into everything, so we don't count 1. 1 would have gone into all the numbers from the beginning. So yeah, we don't count 1. We're just done here. Because there's nothing other than 1 that goes into these numbers. So where's our answer? Multiply down and like an L. Down and across. Remember, it's LCD, LCM, down and across. So 7 times 2 times 2 times 1 times 1. It's 7 times 2 times 2 times 1 times 1. What is that? 28. 4, 14, and 7 all go into 28, don't they? That's the lowest number they all go into. That's the LCD or LCM, whatever you want to call it. If we were doing fractions, which we will on Monday, oh, they might have even a couple in this section, I can't remember. That would be the common denominator.
You couldn't do that at the first.
It's the least common denominator. James?
You couldn't do that at the beginning.
Do what?
Well, just say that 28 was.
Oh, you can. If you can tell it, that's fine. Yeah, if you can just see what the LCD is, feel free to just write it down. Yeah, if you can see the answer, you don't have to go through the steps. All right, so 9, 15, and 5. Give it a try. So what goes into a couple of those numbers? Could be 3 or 5, right? So 3, for example, you could do. 3 goes into 9 3 times, 3 goes into 15 5 times. But 3 doesn't go into 5, so what do? Just drop it down. Now, what's next? What's my next layer? What goes into 2 of those? 5. Am I racing ahead? You good? Now do 5. You could have done 5 first, then 3. The order doesn't matter. 5 doesn't go into 3, so just bring it down. 5 into 5 once, 5 into 5 once. Can I do another layer? Nothing but 1. So we don't do 1. So just times, 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 times. 3 times 5 times 3 times 1 times 1. 45. All those numbers, you might have already known, go into 45. Good? So that'd be the common denominator for them. If you're doing fractions, which we will do. Give it a go. Give it a whirl. You got it? What's the answer?
Oh.
Please get it now? Yes.
I messed up right there.
All right, so what goes into a couple of those? Well, 2. 2 goes into all of them. 2 goes into 2 1 time, 2 goes into 6 3 times, 2 goes into 18 9 times, right? Good so far? Now for our next layer, what goes into a couple of those numbers? 3. 3 doesn't go into 1, so just drop it down. 3 into 3, 3 into 9. What goes into a couple of those numbers? Nothing but 1, so we're done. Times, 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 times. So 2 times 3 times 1 times 1 times 3. It's basically 2 times 9, right? Because it's just 3 and 3 is 9 times 2 is 18. So one of the numbers itself, 18, obviously goes into itself, and 2 and 6 go into it also. 18 itself is the LCM. It's the lowest. A couple people were thinking 36, and they all go into 36, but that's not the lowest number they all go into. The least number they all go into, the LCD, is 18. We're finding the lowest common multiple or denominator. All right, we good. All right, so 5/27 plus 1/6. This is where if you have the Casio natural display, you can just type it in and it'll just do it. It'll just do it for you. So I'm always advertising that calculator.
Saying it's something with 5.
Casio natural display at a retail store near you. Mention my name, Mr. Herring gets a 10% profit. I'm just kidding. I have no
And
no
discount so that I can get limit 10%.
That's right. No, it's just a good calculator. I own 3 of them for my own kiddos. I'm sincere. I put my money where my mouth is. Those things are nice. All right, so 5/27 plus 1/6. Anyway, so we got to take the 27 and the 6, and we got to put them in a box because we got to find the LCD. That's first step. Find the common denominator. All right, can you do that? What goes into 27 and into 6? 3, right? 3 goes into 27.
9.
3 goes into 6. 2. Can I do another layer? What goes into 9 and 2? Nothing. Nothing but 1. So multiply these together. 3 times 9 times 2. What is that? 54? 54. So what does that mean? Now we have to go further. That's going to be the new common denominator. Let me slow down there for a minute. So far it's just stuff we already know, right? Put the denominators in the box, find the common denominator, 54. That means I'm going to make both these denominators become 54. Right? Okay, now, do I just bring down the 5 and the 1?
Nope.
Is that what I do?
No.
Why not? Why? Who's they? The math kings and queens, they just make us follow their rules? Why do they do that? Who are these people that took over the world like this? Wow, that sounded fancy. Give me English language. Why? Why can't we just bring down the 5 and the 1? I like that better.
What's wrong?
Why is it wrong?
That's how it was made. Because I'm always right.
It's because we can't change the fraction. We can only give it a new look. Plastic surgery, right? We can't change it. If I said, I ate 5/27ths of the pie. Oh, really? Well, I ate 5/54ths. That's less pie. That's a different amount of pie. We can't change the fraction. We can only change the way it looks, right? So if you just bring down the same ones, you've changed it, right? Or how about 1/6 of the pie? That's not the same as 1/54th of the pie. We can't change the problem. That'd be a different problem. We got to keep them the same, just looking different. I always call it plastic surgery, right? Give them a new look without changing them. Well, how do you do that? That's why you do the same thing top and bottom. So it'll look different when you're done, but not be different, right? Well, how do you figure out what that is? You divide. You take 54 and you divide each of these. So 54 divided by 27 divided by the old denominator. And over here I'll divide by 6. So what is 54 divided by 27 on your calculator? 2. That tells you what to put top and bottom. Let me slow down there. Did you see what I did? You take the new common denominator, divide by the old one. It'll tell you how many times the old one goes into the new one, 2. So then you do that top and bottom. Why? Because 2 times 27 is the 54. That's what will give it that look. But whatever you do to the bottom, you have no choice but to do the same thing to the top. Otherwise, you'll change the problem. See, math just follows truth. That's who's the king and queens of math. It's truth, right? 2 times 5 is 10. That makes sense? Let's try the second one. Find the new top for the second fraction.
9.
Divided by 6 is 9 on your calculator. So what does that mean? Top and bottom by 9. 1 times 9 is 9. 9/54. We good to there so far? So you divide the new denominator by the old. Let's get 9. And then multiply top and bottom. 6 times 9 is 54. 1 times 9 is 9.
Yeah.
If I took 9/54ths and I reduced it,
The comeback.
what would it become?
1/6.
Alright, then city one.
See my point? It's the same. If I said, I was so hungry last night, I ate 1/6 of the pizza.
Yes.
Oh, really? Well, I ate 9/54ths. That's the same amount of pizza. That's the same part of the whole. That's the same portion. It just sounds like more, doesn't it? Yeah, you see, we haven't changed anything. We've just given them a new look. Why'd we do this new look? Because now we can add them. Now we can add them. You can't add them until the bottoms are the same. Now we can add them. And the answer is 19/54ths.
I'm gonna keep this.
Right?
I'm gonna have grandkids.
Why don't we add the bottoms? I didn't add the 54 and 54. Why don't I add the bottoms? It says plus in the middle.
They're the same. We can.
We only have the top. I know we only have the top, but why?
They're
Keep the same.
same, different look.
You know, all my whys, let me give you the answer for the rest of the semester. Because it's the truth. That's always the answer, yes. That's true. I mean, think real life. If I said I ate 10/54ths of the pie, and then later I ate 9/54ths of the pie, how much pie did I eat altogether? 19/54. It's not 1908 or whatever. That's just the truth, right? That's real life, right? Math is just following the truth. That's all they're doing. Make sense? Casio National Display will do it all for you for a mere $12.95 at Walmart and Target. Plus taxes, plus Mr. Heron's cut. They have a Mr. Heron folder over there. All right, let's try that one. Add those together. So you got to, first thing you got to do is put the 8 and the 10 in an L box, right? Throw the 8 and the 10 in an L box and find the LCD.
Yeah. I hope.
So put the 8 and the 10 in the L box. 2. 2 goes into 8 4 times. 2 goes into 10 5 times. What goes into 4 and 5? Nothing. So you go times times. What's the answer? 40. Good, so then 40 is the new denominator, right? That's the LCD. Right, good. So now we're going to go back and we're going to multiply top and bottom of each of those fractions. Does that make sense? Go back and multiply the top and the bottom of each of those fractions. Because you're giving them a new look without changing their actual value. How do we find what number to multiply?
Divide. 40.
You divide. You take 40 divided by 8, it'll tell you 5. Top and bottom by 5. Good. So that'd be 25 40s. And the other one, divide by 10. You always divide by the old denominator, right?
Yeah.
Be 4. Top and bottom by 4. Be 4 40ths.
Then 29 over 40.
Right. That makes sense so far? And you guys know that's true, huh? What is 4 40ths if you reduced it? 1/10. That's the same thing.
Hence you'll never do.
You haven't been following these math rules all your life without knowing the reasons why, have you? Just obediently following whatever the math book says? That would be boring to me. And I don't know, maybe you feel math has been boring. If there was no good reasons for things. 29 40ths is the answer, right? We good?
Yeah.
All right. All right, 21z squared and 63z cubed. They want the LCM or LCD. All right, so let's do the 21 and the 63 first off. Put them in a box, right? We'll do the letters second. Letters will be super easy, actually. Let's do the numbers first off. What goes into 21 and into 63? Use your calculator if you're not sure. 7, huh? Yeah, 7's a good one. 7 or 3. 3 goes in also. Or 21 would be even better, huh? Good thinking. Any of these are fine. Because 7 goes in there, 3 and 9. Good so far. And then what goes into 3 and 9? 3. Do another layer with the 3. 3 goes in there. 3 goes in there 1 time, 3 times. And then what goes into 1 and 3? Nothing. We're done, right? So multiply these together. 7 times 3 times 1 times 3. It's just 63. 63 is a number itself that 21 goes into. So it's the LCM. So 63. So far so good? Now, those are the numbers. Now, what do we do with the letter? We got z squared and z cubed. Now, up to now, have you noticed that it's the opposite of what we did with factoring? If we were, remember back when we were factoring, like parentheses, number in the front, right? We would have said what goes into both those 21. We would have taken the lower. LCM is exactly the opposite of GCF. It's exactly the opposite. So with that in mind, if I was factoring, what were we trained to do for factoring? We would always take what? The higher or the lower power? The lower for factoring. So guess what we're going to do for this? The higher. You take the higher. That's all you do. Done. Higher power. For LCM or LCD, same thing. It's the opposite of factoring. You take the higher power, which is weird because it's called least common denominator. And we take the highest. And the GCF was called greatest common factor. We took the lower. But that's true. Remember I reasoned with you about the most two people have in common is the lower one? And now we're trying to find a bigger number that they go into. So you need the higher power. You need third power because they both can go into third power. So higher, and you'll be fine. Is that good? So the letters are simple. Just grab the highest one. And the numbers you do with the L box. So it's the higher power. Monday will be hard. Monday it's appropriate to go, Monday will be rough. But today's not bad. Monday's gonna, these are all gonna be in big old letter fractions on Monday. All right. So let's do the LCM. So put the 35, the 5, and the 21 in a big old L box. Right? Do that part first. And then after you're done with that, just grab the highest power on B and the highest power on C. You're done. So do the numbers first off. What goes into two of those? 7 or 5. You can start with either one. Like I'll do 5. 5 goes in there 7 times 5 goes in there once. 5 doesn't go into 21, so just bring it down. Good so far. Just bring it straight down if it doesn't go in. Doesn't go in evenly. Good so far. What goes into 7, 1, and 21? 7. 7 goes into 7 one time. 7 doesn't go into 1. 7 goes into 21 3 times. Good, and nothing goes into those, so multiply them together. 5 times 7 times 1 times 1 times 3. Yeah, it's 105, right? So 105, and now what do we do with the letters? Highest, highest. What's the highest B? You got B to the 4th, B to the 3rd, B to the 5th. Who's the highest B? B to the 5th. That's a funny looking 5. And what's the highest C?
7.
C to the 7th. Done. 105, B to the 5th, C to the 7th. So the letters are easy. Just grab the highest for each one. It's the opposite of factoring. Because why it's the opposite is because we're not finding a little thing that goes in. We're finding a bigger thing they fit into. That's why it's the opposite. We need something bigger than them that they can fit into. It's got to be able to hold them all. It's going to become a common denominator on Monday. All right. Let's try this one. So p squared minus 4 and p squared plus 6p plus 8. In the interest of time, I'm just going to do the factoring for you real quick so we can talk about what it all means. So that's an FL. This one's a multiply add. So it's going to be plus 2 plus 4 because those multiply to be 8 and add to be 6. So we good. So you just factor them. Here we go factoring again whenever you have parentheses or... Well, it's because we have pluses and minuses. Yeah. See how we have pluses and minuses all of a sudden? Costco glue, huh? Whenever you have that plus or minus Costco glue stuff, that's when you factor. Okay, now, how do we find the LCM? Let me give you a nice, easy rule. The LCM is one of each type to the highest power at any one location. That's how you do the LCM. Remember what we talked about? It's the highest power at any one location, right? So the LCM will equal... Am I going too quick? Are you ready? So you take one of these, and one of those. P plus 2, P minus 2, P plus 4. Done. In other words, you don't need to double up on the P plus 2s. You just take one of each type to the highest power they have in any one location. But nobody has any powers on this one. Usually they don't. So everybody getting that game plan? It's only one of every variety. One of every type for the LCM. Makes sense? Okay. So u to the third plus 10u squared plus 25u and u squared minus 10u. So again, I'm going to just factor it for you automatically. And then just let you do the finish part. So I'm just factoring it quick. So I just factored those. So everybody good with how I factored that? So I took out a u, because they all had a u in common, GCF. So remember, when they have pluses and minuses, that's the Costco glue. We're always factoring to get around that Costco glue problem, right? See the pattern? The pluses and minuses, we're always factoring to get around the Costco glue problem. So I took out the u they had in common, and then I did the u plus 5, u plus, you remember, multiplies to be 25, adds to be 10. Good there. And then over here I just took out a u. Good there. Now look at this. Identical twins. What do we always do with identical twins? Squared. Right? We good there? So we're looking at this and this. And we're saying, what's the LCM? What's the rule? One of every variety to the highest power you see in any one location. Do you have those two rules straight in your mind? One of every variety. It's like you're going to the store. You're shopping, Target. You think, today I'm going to buy one of everything. That would be expensive. I'm going to buy one of everything. I'm going to buy one of these U's. I'm not going to take that one. I've already got one. I'm going to buy one of these U plus 5s. And I'm going to buy one of these U minus 10s. But this one's squared, huh? That's it. Any order. You can switch the order up. The order doesn't matter. One of every variety. Do you see, guys, why I did not take U squared? We're only taking one of every variety. But why did I take U plus 5 squared? Because there was squared in one location. See the difference? You're not adding things up. You're not going 1 U here, 1 U here is 2 U's. We're not doing that. We're only taking one of every variety, the highest power we see in any one location. Oh yeah, we always finish with a clicker. G plus 3, G minus 3 squared, G squared minus 9. Only one of those needs to be factored. Which one of those has the...
G squared minus 9.
Yeah, do you see that this one needs to be factored? Whereas this guy, he's just first power. Nothing can happen there. This one's already factored. But this one is, what do you do with G squared minus 9? G plus 3, G minus 3, right? Whoops. G plus 3, G minus 3. Some fancy princes. All right. So looking at this, and this. Let you write the LCM. Yeah, that's a little tricky. See if you can apply that rule.
The G minus 3 would be by itself compared to like the G or the G minus 3 squared, right?
Right. Well, I'll put it on the board in a minute. So remember the rule. The rule is one of each type, right? One of each type. So I'm only going to take one G plus 3 and one G minus 3. First off, I'm going to do some powers in a minute. But first off, that's the only types up there. You agree with me? One of each type. Now, how do you know what power? To the highest power, not the total. You don't add them all up and take the total. To the highest power in any one spot. Remember that rule I wrote? So you take one of each variety, one of each type, but you take the highest power of it that you see in any one location. So I'm going, what's the highest G plus 3 I see anywhere? Just right?
G plus 3.
What? I don't see the G plus 3 squared.
No.
What's the highest G minus 3 I see anywhere? Squared. I see a squared on that one. So that one I will take squared. Does that make sense? Do you see why it's just regular G plus 3? Because the mistake students make a lot on the exam, I see is they'll go, oh, there's one there and one there, I need squared. We're not totaling. We're not totaling. We're taking the highest in any one location. All I see with G plus 3 is regular. plus g minus 3x
Squared.
Question,
So we're not cancel anymore?
we're not what?
Not cancel?
Oh, no, this isn't canceling. No, this is just, because this isn't a fraction. Yeah, this is just find the LCM. All right, well, that's all we have time for. We now click A. A for apple. And you're in there, and we're done. So these 3 sections are due.